Hi, my name is Anika Valaru, and this is my lab report for Lab 2 in Physics 2212. The purpose of this lab is to observe the effect of the magnetic field of a bar magnet at different distances using both experimental data and a computational model. The models and principles involved are the Biot-Savart law, magnetic dipole, distance dependence, magnetic field, and the various equations as shown here. Assumptions and initial conditions include nothing is interfering with the magnetometer except the bar magnet and the Earth's magnetic field. The found location of the magnetometer sensor is exact, and there is no error with the phone, and the phone did not shift during measurements. The materials involved are clear tape, a ruler, measuring tape, my phone with the magnetometer, and a bar magnet. So here's a preview of the results. N was found to be negative 2.98. K was found to be 2.202 times 10 to the negative 6. Mu was found to be 11.01. The off-field net magnetic field was, in the experiment, 6.02 times 10 to the negative 5th, and in the model, 5.06 times 10 to the negative 5th. So main ideas, we're looking at interactions with magnetic fields. The system is the bar magnet, and the surroundings are the Earth, my phone, and everything else. So for the setup of the experiment, I followed the instructions to ensure my phone was parallel to the Earth's magnetic field and the bar magnet was perpendicular by tilting my phone until the magnetometer was reading 0 in the x direction. I also found the location of the sensor according to instructions. So I used it's keeping the same angle as before. I used my measuring tape and I moved my phone up and down until the magnetic field in the x direction was at a max and the magnetic field in the y direction was at a minimum. And then I put a tape there, and then I did the same thing while flipping my phone to the horizontal direction, finding a max magnetic field in the y direction and a minimum magnetic field in the x direction, and then I put another tape there, and then the intersection is where the sensor is located. So in the experiment, I then found the distance dependence on axis of the bar magnet using the spreadsheet and doing some calculations. You can see my calculations on the right, and you can see what the graph looks like from the spreadsheet above. So as I said earlier, N was negative 2.98, K is 2.202 times 10 to the negative 6, and mu is 11.01. I found that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. And as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. So afterwards, I followed the instructions and used the spreadsheet to find the off-axis magnetic field. So first, I put the distance of the bar magnet at a point where the net magnetic field was about 100. And then, so that turned out to be 23 centimeters. And then I moved the phone upwards 23 centimeters, and you can see all the numbers I put in, all the calculations the spreadsheet did, and the net magnetic field was found to be 6.02 times 10 to the negative 5. So in GlowScript, I started with the starter code. I added in all the relevant values I found, such as d perpendicular. I added a def for dipole B. I added arrows to show the field, and I changed the scale so that the whole image could be seen properly. So you can see these parts of the code here. And then here's what the code looked like as shown earlier. BNet was found to be 5.06 times 10 to the negative 5th, which is a bit lower than the experimental value. You can see the direction of the magnetic field here. The blue ones are perpendicular and the orange ones are parallel. So similarities, differences, and errors. Similarities, the arrows are in the same direction as they would in real life. Differences, the net magnetic field did not have the same magnitude in both the experiment and the computational model. Errors, there may have been other metal or magnetic objects nearby. I don't think there were, but there may have been. My measurements may have been inaccurate, and the phone may have shifted a little incorrectly during measurements. So what if If I hadn't oriented it properly in the beginning, the readings would have been lower because the Earth's magnetic field would have been interfering. The difference in the experimental values and the computational model could have been bigger or smaller depending on the angle. And then imagine there were two magnets stuck together. The directions of the magnetic field would have stayed the same, but the magnitudes would have been twice as large. Thank you for listening to my lab report.